So our question says we have a lead bullet with a mass of 15 grams. So I write it as m sub b, and it's zero. I convert it into kilograms. So 15 grams is 0.015 kilograms. It's fired at a fixed block of wood with a mass m sub w of 35 kilograms. So they embed together. So after thermal equilibrium is reached, the temperature rises delta T by 0.02 degrees Celsius. So it wants us to estimate the bullet's entrance speed based upon this information. I also write the constant for lead, C sub L, is 130 joules per kilogram times degrees Celsius, because that's what the bullet is made out of, lead. And then C sub W is 1700 joules per kilogram times degrees Celsius. That's for wood, C sub W. Okay, so we're going to assume that the initial kinetic energy of the bullet all goes to heating the wood and the bullet since it's stopped. So therefore, the initial kinetic energy of the bullet is 1/2 mass of the bullet times that initial velocity, we'll call it v sub I, that's what we're trying to find, squared. All of it goes to heat, Q, that's the energy, and that's equal to the mass of the bullet times the constant C, heat constant here, of the lead, because that's what the bullet's made out of, times the change in temperature of the lead, delta T. But that's the same delta T, since the lead and the wood change by the same temperature, that's just delta T. So that's going to be added to m sub W, mass of the wood, times C sub W, times, again, the wood changes by the same delta T amount, so times delta T. So now we can solve this equation for v sub I. Well, v sub I squared, so to get rid of the squared, we're going to have to square root it. So v sub I is equal to the square root. I'm going to pull the delta T out front since it's the same in both. Delta T times mass of the bullet, m sub b, times C sub L, plus mass of the wood times C sub W. Close the parenthesis. And all that is going to be divided by 1/2 times the mass of the bullet, m sub b. So plugging all those values into the expression, there we find that this is equal to 398.3. And the units here are, of course, meters per second, since we were using SI units. We can box that in as our solution to the question.